Good day and welcome to the Math Salon. My name is Dr. Numenem. For those of you who are new to the Math Salon, feel at home. You're welcome. Relax and watch the video. In our Math Salon, we try to help the students develop their skills in mathematics. Stress on the places where they have to pay a bit more attention when they learn or study mathematics. This is a special day today because here we'll be trying to solve some questions that we had given to the students in our first ever Math Salon quiz. So I will try to go step by step explaining to you what you were supposed to do, or at least what we expected. This is not the only solution or what I would show you here. There are many other ways of doing it. That's the beauty of mathematics. Get into the salon, you come out much more beautiful than you went in. Okay, let's go. So question number one, you were expected to factorize this expression. And when it comes to factorization, the most important thing is to see that you factorize only when you have things that are common, things that look alike, say. So it means that you have an expression like this, try to gather terms that look a bit similar to each other so that you can pull out what is common. If that is the case, I would look at this part here and say this is 169 alpha squared minus 9 beta squared. And I shift these two terms this way. So this is plus 12 beta minus 4. You see, this looks much more beautiful as I get beta squared, beta, and beta 0 if you want to say that. So this looks like a quadratic equation in beta. So if I have to do that, I have 169 alpha squared. It's always important to manage your minuses as well. Minuses are really tricky in mathematics. And if you don't manage them well, you risk to make a mistake. So if I factorize minus 1 here, then I'm going to have positive 9 beta squared. But this was plus, so if I remove minus, I have to make it minus, so that minus times minus give me back the plus. This was minus, it becomes plus, so that minus 1 times plus 4 becomes minus 4. I'm left now just to factorize this expression. This is a quadratic expression, so you can do it in several. You can use discriminant, you can use quadratic equation formula, whatever you want. But I would use what I think is simple here, which is simply look for factors of this term and look for factors of this term so that when you cross multiply, you should have the middle term. So this is 3 beta here. 3 beta times beta is 9 beta squared. And this is minus 2, minus 2. It could be plus 2, but because I have minus, I have to choose factors that work. Minus 2 times minus 2 is plus 4. And if I can check that that is true, minus 2 times 3 beta is minus 6 beta. Minus 2 times 3 beta is minus 6 beta. Minus 6 beta minus 6 beta is minus 12 beta. So it means these are my factors, these two here. So I can write this now 169 alpha squared minus 3 beta minus 2, all that squared because it's 2, one and the other. This time that squared. 169 is 13 squared. So I can write this like this. If I open this bracket, I get back this. This will be 13 squared, which is 169. This alpha, which will become alpha squared. Minus 3 beta minus 2, all that squared. If I look at this, I recognize this as the difference of two squares. What's the meaning of that? Say if I have difference of two squares like this, the factors will be a plus b times a minus b. We can show that this is true by simplifying the right hand side. A times a is a squared. A times minus b is minus ab. B times a is plus ab. B times minus b is minus b squared. You see, they cancel and it's true. So it means I can now take this and express it in terms of those two factors. And this is now equal to my a there, 13 alpha plus 3 beta minus 2. My a again, 13 alpha minus 2 bracket 3 beta minus 2. And if that is true, then this is 13 alpha plus 3 beta minus 2. If I open this minus here, this is minus 3 beta and this becomes plus. That's 13 alpha minus 3 beta plus 2. If you look at the expression, it's exactly that one. So this is just written in nice form. Minus 3 beta plus 13 alpha plus 2. So the answer was B then. Thank you. We'll move to the next one. For the second question, this was about being able to follow instructions. You're given the definition of something and how you can use it in order to solve a mathematical problem. You were told here that this notation is a factorial notation. That this is a factorial notation. And we're told, for example, n factorial means n times n minus 1, n minus 2, n minus 3, 3, 2, 1, for example. That means if I had like 5 factorial, that means 5 times 4 times 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1. If you notice this, you see that this is exactly this. So it means I can write this as 5 times 4 factorial. That's a bit the idea. So you can actually play with it. If you try to use the calculator, this would have said error if you try to look for that. So the intention was to make sure that you use some knowledge of playing around with also factors, as you see there. So I can see that 4 factorial is a factor in 5 factorial. So if that's the case, then my x here is equal to the square root of 225 factorial all over the square root of 221 factorial. From your knowledge of roots and surds, you see that we can actually push this up, and I can only get one root here with 225 factorial over 221 factorial. Then I can use now a bit the technique I have here, because this will be a factor in that one, since that one is bigger. So this is the square root of 225 times 224 times 223 times 222 times 221 factorial divided by 221 factorial. Yeah, that's the definition. You see, I could continue, but if you continue, you only realize that the rest of that stuff will be exactly what is below. In this case, this one can fall off, and I'm left only to look for this root of this product. 225 times 224 times 223 times 222. And if you do that well, you should get an answer like 49950.99. And to the nearest integer, you get 49951.